Assalamualaikum and very good morning. Okay, today I will present about log decrement. Okay, first of all, this is the graph that we get from the spring for 40 Newton, 60 Newton, 80 Newton for the first spring, and then this one for the second spring, which is 40 Newton, 60 Newton, and 80 Newton. Okay, the data that we get to define the value of the amplitude is this one. Okay. As you can see here, the first value is 0.99, which is the x-axis, and then the 0.0801 is the amplitude for the shape of the graph. Okay, the 0.08 is the amplitude one. Okay, the y-axis. Back to the slide. Okay, now after that we will go to the stiffness. This is the graph. Okay, this is the period, how we define the average period. Okay, the three readings here divide to 3, and then we get the true value for the period one. Okay, after that frequency, the time. Okay, for example, the sample one is spring 2, which is a 40 Newton, is 0.356 seconds. So 2 pi over 0.356 seconds equal to 18.722 radians per second. Okay, after that we will try we'll define for the ratio of frequency, which is a square root k over m. K is the stiffness for the spring. For example, this one is for spring 2, which is the stiffness for the spring is 1386.7 Newton per meter. Okay. And then after that, we'll try to find the delta 1 over n. Just put a 1. So 1 is 1. So just cancel out. And then the ln, this one is the value for the graph, first amplitude and then second amplitude. For the delta, you will get the value is 0.0929. And then after that, damping ratio. Okay, this one is the formula for damping ratio. 1 plus 2 pi over delta. Delta just substitute from the value 0.929 here up the top. Okay, and then of 2. Okay, for the damping ratio, you get the value is at 0.014786. Okay, which is the experimental damping frequency. Okay, the formula is omega square root of 1 over the damping ratio of 2, and then just substitute the value and we'll get the answer for the experimental damping frequency is 18.4395 radians per second. I think that's all for me.